Welcome to video 8.4e, proving proportions with similar triangles. All right, this is example 6. I'll mark it up as we go. Given YSTW is a parallelogram, that's this big figure. SX is perpendicular to YW. And SV is perpendicular to TW. Notice I marked those right angles inside of those triangles because I just think I'm going to be going for triangles. All right, so this is the tricky thing. Prove this product. So whenever I see a product, I like to go backwards and make it be a proportion because that's what I do with similar triangles. So I'm going to go backwards and say this is really the same as SX over somebody equals somebody over YW. Again, just make sure that those are in the same diagonal buddy. And then over here, make sure that these are in the same diagonal buddy. So I could just say SV and WT. Okay, once I do that, then I'm looking for triangles. So let's see what I've got here. SX is here. SV is here. But then WT is way over here. That's not part of a triangle. And YW is right up there. That's not part of a triangle. But this is where you gotta think a little bit. Oh, they said we're a parallelogram, so opposite sides of a parallelogram are congruent. So when they really said WT over here, that's the exact same as YS. So I will be looking for this blue triangle here. And when they said YW here, that's the exact same as ST down here. So I'll be looking for those triangles, and I'll be doing some substitution. So just to let you know, this is going to actually turn into the following. SX over SV, instead of WT, that's going to be YS. And instead of YW, that's going to be ST. So this is really what I'm going to be looking for. Okay, I can get these triangles similar by angle, angle, right angle, right angle. And again, if I'm a parallelogram, opposite angles will be congruent. So now I've got a plan, get these triangles to be similar, get this proportion, cross multiply, and do some substitution. Game over. Okay, so let's start by getting the triangle similar. I'll start with this. YSTW is a parallelogram. Given, based on that, I got these opposite angles to be congruent. So angle Y is congruent to angle T. If parallelogram, then opposite angles congruent. That's one of my angles in angle-angle similarity. Then I'll use these statements over here. SX perpendicular to YW. SV perpendicular to TW. That was given. Then I'll establish my right angles like we've been doing since week 1. Angle, I'll go SXY. And angle, I'll go SVT. Are right angles. If perpendicular, then right angle. And then the right angles will be congruent. Angle SXY congruent to angle SVT. If right angles, then congruent. I now have my two angle pairs, so I've got the triangle similar. Triangle, whatever, I'll go SXY is similar to triangle SVT. Angle, angle similarity. From that, I'll get this proportion here. I'll be careful with the ordering. So let's just check. SX over SV. So that's first two over first two equals ys, that's first and last, over st, that's first and last, so that makes sense. Then I'll cross it off. So then I'll get sx times st equals sv times ys. I better put the reason over here. If similar, then corresponding sides proportional. This was cross multiply. You need one more step, sorry about that. Step 9, I'm going to use my parallelogram properties. So I'm going to say WT is the same as YS, and I'm going to say ST is the same as YW. If we're a parallelogram, then opposite sides are congruent or have the same distance. And then finally, step 10, I apologize. All I'm going to do is, wherever I have a YS, replace that with a WT. And wherever I have an ST, replace that with a YW. And that should get me what I want. So then I'll say SX times YW equals SV times WT. And step 10, that would be substitution, step 9 into step 8. Step 9 into step 8. Whew. So there you have it. Another proof with proportions and similar triangles.